Buddy, today we are starting on how to find rational discontinuities, that is, vertical asymptotes and holes. Today we will be talking about how to find them algebraically or by hand, whereas Thursday and Friday we'll be talking about how to find them in the calculator. I will also show you today how to check them with Desmos. But the main focus is how to do these by hand. So let's talk about what rational discontinuities are, and we'll start out by defining what makes a function undefined. Well, a rational function, is undefined at any input or x value that makes the denominator equal 0. Okay, we'll show you how that works here in a minute. But continuing on, rational discontinuities or undefined points occur at any input or x value that makes the denominator equal 0. All right, so today we're talking about vertical asymptotes and holes. A vertical asymptote is a vertical line which the curve approaches as it heads toward infinity. Okay, so whether it's a very large numbers or very small numbers, the curve ends up getting very, 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 very close to this line, but does not cross it as it goes towards infinity. That doesn't necessarily mean it can't cross it earlier, but it will not cross it as it heads towards infinity. Vertical asymptotes correspond to the zeros of only the denominator of a rational function. A hole, another type of discontinuity, it exists on the graph of a rational function at any input or x value that causes both the numerator and denominator of the function to be equal to 0. A hole in the graph, you can kind of think of, I've given you a picture of this bridge that's missing a plank, and that's kind of what it is, right? If you consider the bridge as a curve or a line, well, then you can go along that line and it continues on until you get to the hole, and then pretty much, yeah, you simply jump over it and keep going. Okay, so it's just a discontinuity in the graph. It is infinitesimally small since it occurs at only one point. One hole occurs at one point. Which, yeah, there's kind of a visual representation. To find the domain, given these discontinuities, we would say that x does not equal any value where a discontinuity occurs. How we would write that in inequality and set notation, for example, if we had a discontinuity at 3, okay, when x equals 3, then the graph was undefined. We would write simply x does not equal 3. In set or set builder notation, we have our brackets and then we put x, and the bar kind of stands for such that. So x such that x is an element of all real numbers, and x does not equal 3. So it can equal any number that you can think of except for 3. When with multiple discontinuities, we would just list them all with a comma in between from least to greatest. For example, if we had discontinuities at -2 and 5, we would say that x does not equal -2, 5. And we would repeat that with set builder notation with the brackets and the x such that x is an element of all real numbers. In interval notation, all right, it's a little different. For one discontinuity, we would say we come from negative infinity on the left. We go to where the first discontinuity is located. Right? Both of those get parentheses since the discontinuity is not included in the domain. We would use this u, which means union, and then we'd continue on from the first discontinuity, comma, and we'd keep going to infinity. For example, using the first example of if x did not equal 3, it would be negative infinity to 3, union with 3 to infinity. For the multiple discontinuities, no matter how many they are, we would go negative infinity to the first discontinuity, union with the first discontinuity to the second discontinuity, union with, let's say, the second discontinuity to the third discontinuity, et cetera, for how many they are. And then the last discontinuity would continue on to infinity afterwards. If, again, using this second example, negative 2 and 5, the domain would be negative infinity to negative 2, union with negative 2 to 5, union with 5 to infinity. All right, so how do we find these discontinuities algebraically? Well, of course, any discontinuities occur when the denominator equals 0, right? Whatever x value makes the denominator equal 0. So to find that algebraically, we first have to factor any quadratics or any equations, expressions that we have in the numerator and denominator. We do the numerator so we can tell if either of the discontinuities is a whole. All right, so factor both the numerator and denominator. All right, and then we are going to solve both of them. That is, identify the zeros of the numerator and the denominator. So x squared minus 25 factors to x minus 5, x plus 5. X squared minus 8x plus 15 factors to x minus 3 times x minus 5. If you need a review on factoring, we did that last week, but there are plenty of great videos on our YouTube channel. All right, so when we find the zeros, okay, which means that if I substitute 5 for x in the numerator, 5 minus 5 is 0 times 10 will still equal 0. All right, and negative 5 plus 5 is 0 times negative 10 would equal 0. Okay, so both of those numbers will make the numerator equal 0. In the denominator, we have 3. If I substitute 3 for x, 3 minus 3 equals 0 times negative 2 would equal 0. So 3 makes the denominator equal 0, as does 5. 5 minus 5 is 0, times 2 is 0. All right, so what we're going to do, since wholes occur at any x value that make both the numerator and denominator equal 0, we are going to circle any zeros that occur in both the numerator and the denominator. All right, and if we do have the same 0 or the same factor in both the numerator and denominator, we're going to circle that, and that is the x value at which our whole will occur. So in this case, we'll have a whole at x equals 5. Any other zeros in the denominator that are only in the denominator are going to be where our vertical asymptote or asymptotes occur. In this case, 3 does not have a matching 0 in the denominator or in the numerator. So x equals 3 is where our vertical asymptote would occur. And you can see this, okay, in the graphic I have provided. Okay, here is where the whole would occur at x equals 5. I've drawn a little hole around it. Okay, and this is where the vertical asymptote would be. On Desmos, all right, you can see that there it is at x equals 3. There's our vertical asymptote. And if I drag along this curve at x equals 5, you'll see the hole appear. See how it goes open circle right there? That's where the hole is located. Okay. Now, again, to write domain in this situation for inequality, all we say is x does not equal 3 or 5. Those are our discontinuities. So basically, any zeros in the denominator will be excluded from the domain. So x does not equal 3 or 5, which are in the denominator. Set builder, we just add the extra stuff. And interval, we have negative infinity to 3, union with 3 to 5, union with 5 to infinity. Okay, so that's your introduction. on the next video.